Okay, welcome everybody. I'm going to start off with a quick poll. Who in the audience has ever heard of IAM Roles Anywhere? Wow, that's actually more than I expected. Most people, when I told them I was going to be talking about this, they're like, what the heck is that? I've never heard of that service. So today I'm going to be talking about this service and how you can use it to reduce the risk of using those pesky static IAM keys. And why are they so pesky? Anyone recognize this email? You ever received an email like this? It says, "Dear AWS customer, we found your access key on a GitHub repo." You may not know this, but AWS is constantly scanning public repos for access keys. And when they find one, they will deactivate it in your account and they'll send you an email like this. So no judgment. Who's got an email like this? Raise your hand. Okay, a few of you. All right, what about this one? Have you gotten this email? "Dear AWS customer, your account has been compromised. And we see that you've run up $20,000 in spending in the last 4 hours." Anybody got an email like this? Yes, that is a particularly alarming email. So these are the kinds of emails you get when you use access keys and they get exposed, right? There are hackers out there that are looking for access keys all the time, and they find them and they go and they spin up Bitcoin miners in your account and start racking up charges. So before I dive into it, my name is Mike Graff. I'm an Infrastructure Architecture Director at Dolby Laboratories. We're based in San Francisco. We are a media and entertainment company. You may have heard of us. We're responsible for things like Dolby Atmos and Dolby Vision and surround sound and all that good stuff. I've been working on the cloud since 2015. I'm a member of the AWS Community Builders Program for the past 4 years. Hold a few AWS certifications. I'm also pretty active in the FinOps community. And I blog about cloud governance and FinOps on my personal blog, which is cloudyadvice.com. And if you want a sticker like looks like that, come see me after the talk. I've got a few left. So, static keys problem. What is the risk? Well, I think we've already kind of talked about the risk, right? It's not an awesome solution for giving external access to systems to AWS, but it's one of the only ones we have. So you generate that IAM access key, you hand it to your developer, and you keep your fingers crossed that they don't share those keys with somebody, or that they store them in plain text on their computer, or that they put them inside their code and upload it to GitHub, because then you're going to get that email that I showed you a few minutes ago, right? And then there's also the toil of managing those keys. Beyond just the risk, if you're going to use these keys, there's a lot of work involved, right? You need to be rotating these keys on a regular basis. Where I work, we do it every 75 days. Which means every 75 days you're generating a new key pair. You're giving it to your developer, hoping that it doesn't get compromised in transit. They have to rotate it on their system. You have to then go disable the old access key, right? Wash, rinse, repeat, do this every 75 days. That's a lot of toil, and we don't like toil. So some of you are in the audience are probably thinking, well, what about instance roles, right? IAM instance roles, if you're familiar with that, that is essentially a mechanism for associating an IAM role with an EC2 instance or a container or a Lambda function in your account that allows it to dynamically get credentials using the metadata service and putting those credentials and using them to execute within commands within AWS. Great feature, very slick, eliminates the need for access keys. There's just one problem. It only works inside of AWS, right? So up until recently, the only way to handle this was to be using those lovely static access keys. So fast forward to 2022, AWS launched this service called Roles Anywhere. It's a mechanism for external servers, containers, applications to obtain temporary credentials in a manner kind of similar to EC2 instance roles, but a little bit different. It eliminates the need to create and manage static access keys and makes your AWS account a lot more secure. So Roles Anywhere actually leverages public key infrastructure as a mechanism to establish a trust between your external system and the AWS account. Systems sitting outside of AWS are issued an X509 certificate. They then present that certificate as part of a session request to the Roles Anywhere service. And in return, Roles Anywhere sends you back session credentials that are temporary in a JSON format. So that's the summary of how it works. Let's talk about what are the key components of Roles Anywhere that you need to have in place to use this service. The first is a certificate authority. Everyone in this room, this is a security conference, everyone knows what a certificate authority is, right? But it's basically the heart of your public key infrastructure and it's responsible for issuing certificates. With Roles Anywhere, you can use your own external CA that you've already built, or you can use a private CA service offered by Amazon as part of Amazon Certificate Manager. Next up is the certificate. So certificates are digital key pairs, contains the public key and a signature that has been encrypted with the private key. This allows a third party to verify the certificate is valid by decrypting the signature using the public key. And certificates also contain a trust chain that validates where the certificate came from. The next component is a trust anchor. This is used to establish a trust relationship between Roles Anywhere and your certificate authority. Next, we have an IAM role. Everyone in this room knows what an IAM role is, right? It's an identity that contains specific permissions that you're allowed to assume if you have permissions to assume it. Now, in order to use a role with Roles Anywhere, you need to update the trust policy so that it's going to trust the Roles Anywhere service principal to be able to use it. Next, we have the Roles Anywhere profile. Profiles are used to specify which IAM role can be used with Roles Anywhere and what workloads can do with the credentials that are part of that role. You can optionally even set a session policy inside of that role profile to limit what permissions it can execute. And then last but not least, we've got the credentials helper. This is a downloadable tool provided by AWS that allows you to to request temporary credentials via the Roles Anywhere endpoint via something called the Create Session API. Okay, that's the components. Let's go through the architecture real quickly. So first, we have our trust anchor, right? As I mentioned, this is going to associate your certificate authority with the Roles Anywhere service. The CA, as I mentioned, can be running inside your on-premise data center. It can be sitting in AWS, or it could even be sitting inside of another cloud account. The CA then issues an X509 certificate for your external system, where you place it on the local store on that system. You configure an IAM role that has the permissions that you want to grant access to the external system. And then you have the Roles Anywhere profile that associates the role with Roles Anywhere. Once you have all these components in place, the workflow is that your external system will issue a create session request, which contains the certificate as well as some variables that are the assume role specification, sends it to Roles Anywhere. Once Roles Anywhere validates that the certificate is valid and that the session is authorized, you are authenticated, and Roles Anywhere will send you back some temporary session credentials that are minted via STS. So that is the architecture. I've talked through why you would use it, what is the architecture. Now let me talk you through kind of an end-to-end walkthrough of how we deploy this service. So part one of setting up Roles Anywhere is you got to have that CA, right? So for my lab deployment of Roles Anywhere, I use Certificate Manager Private CA as my certificate authority. But you could just as easily use an existing CA if you already have one. You probably are most familiar with Certificate Manager as a service for issuing public certificates for use with AWS services like CloudFront or API Gateway, or just for installing on web servers. But there's also another component of AWS Certificate Manager, which is the private CA service. This allows you to set up entire managed CA hierarchies without the headache of managing your own. And show of hands in the room, who has set up and managed their own PKI? And did anyone find that to be a fun experience? I'm going to say the answer to that is probably no. So to get started with setting up Amazon Private CA, navigate to the Certificate Manager service with the appropriate credentials in your account, and click the link for the Private CA service. And from here, we're then going to click the button that says Create a Private CA. Now it's wizard time. So we're going to go through the wizard here, where we're going to set our CA mode option to be general purpose. There's another option for CA called short-lived. That would not really be appropriate for Roles Anywhere. Your CA type to start with is going to be a root CA. That's the top of any PKI hierarchy. And then set your subject DN information as you please. You know, your organization, OU, country, state, locality, et cetera. Then you set your key algorithm, right? Here I'm doing RSA 2048. The second part of the wizard is to set up the CRL. You cannot have a functioning PKI without a public CRL location. Other systems will not trust your CA if there's not a CRL. So Private CA allows you to set that up very easily. You just check the checkbox for Activate CRL, and create a new S3 bucket, put your S3 bucket name in there, apply your tags as appropriate, and then you need to also give the CA certain permissions. Specifically, we need to authorize ACM the ability to renew certificates, right? So that when the certificate expires, it will automatically renew it for that client. Then you need to check the checkbox that says, I'm going to be charged a monthly fee for running private CA. Now, last time I checked, the monthly fee for this was $400 a month. So if you're doing this in your lab, just be prepared for that, right? Have those AWS credits queued up and ready to go so you can take advantage of that, or turn it on for a day and then turn it off, okay? So that's the CA configuration. Once you've done that, your CA is created, but it's not active until you actually have an installed CA certificate for the CA. You go to the Actions menu of the CA homepage and you say, Install CA certificate, and then you're going to get to this screen here. We're going to take the default validity period of 10 years and the default signature output of SHA-256, or tweak it however you want, and then click Confirm and Install. What happens next is it's going to create that certificate, install it. Now, there's probably some security people in the room who are cringing right now, right? Do not issue certificates from your root CA. That is not a best practice, right? Your general idea is you're going to have a root CA, and then you're going to have one or more issuing CAs that would actually issue certificates to clients. For the purposes of my lab, I didn't do that because I didn't want to pay $800 a month, right? So I just set it up with a private CA and I issued certificates directly. But I just want to say, for everybody in the room, do not issue certificates from your root CA. The only certificate the root CA should be issuing is for the issuing CAs. All right, so with that caveat out of the way, let's talk about configuring roles anywhere. To get started, you go to the IAM service page. From the left-hand navigation bar, you're going to choose roles, and then if you scroll down, you'll see this box here that says Roles Anywhere. Click the Manage button, and you're going to be taken to a nice wizard that it has for configuring all the components of the Roles Anywhere service. And the first thing we need to do is set up that trust anchor that I showed you in the diagram, right? So there's an orange-red button there that says Create a Trust Anchor. You click that, and guess what? It's another wizard. Right? We're going to enter a friendly name. We're going to select our private CA that we already created here in the dropdown. Right? Now here would be the option if you wanted to use an external CA, you could check this box here that says External Certificate Bundle, and you have the option to upload a certificate package from your own CA. Right? I'm not doing that in my lab. I'm just using the Amazon private CA. So I just select that from the available list of CAs in my account. There's only one. I leave all my notification settings as default, I attach my tags, and then I click Create a Trust Anchor to complete the process. Now we have our trust anchor in place. The next step is we need to configure a role. So that's this component right here, right, the IAM role. If you have an existing role, you can use it. As I mentioned before, you could just simply need to update the trust policy on the role to trust the Roles Anywhere service principle. But in this case, I'm going to make a new role, right? So I click the Create a New Role button, and that's going to take me directly to the IAM Roles creation page. First step is I need to tell it what AWS service I'm going to be using for this role. So that's down here. I collect the box for AWS service, and then I say I'm going to be using it with Roles Anywhere. After you click Next, the next step is to attach permissions. And as you know, when you're building a role, you can add one or more permissions policies. You can use custom ones that you built yourself. You can use AWS managed policies. You can even attach multiple at once. In this case, I'm just using the real basic Amazon S3 read-only access to test out my Roles Anywhere service. To finish it out, give your role a name, review the trust and permissions, and click Create Role. Once you have your role created, we need to go back to the Manage Roles Anywhere screen, where the final step is to create a profile that will associate your role with the Roles Anywhere service. This is a required step to make the role accessible for use. So again, you just click the button that says Configure a Profile, and you're going to have, guess what, a wizard. Who doesn't like wizards? Right? We're going to name our profile. We're going to choose the role that we created from the role dropdown. And then there's this section here called Session Policies. And I talked about this, where you can customize what the what can be done with this role when it's being used via Roles Anywhere. This is important because the default setting here is all. So you want to go in here and remove the default inline policy that says give all permissions, right? Take that out, set your tags. We're all using tags. And then we click the Create a Profile button to create that profile. Deep breath, right? We've just gone through, we've configured the entire back end for Roles Anywhere. It's ready to go. The next step is get your external system ready to use Roles Anywhere. So the component that goes on the external system is that X509 certificate, right? And that is what is used to issue the signing request, sorry, the session request to Roles Anywhere. We're going to issue that certificate from Amazon Private CA. Again, you would be doing this from your issuing CA in a real-world environment, not from my root CA, right? But you go back to Certificate Manager, you click the button for Request Certificate, and then the certificate type is a private cert. You click Next. You go through and complete the wizard for doing a certificate signing request to the CA, right? If you've ever done a certificate signing request, this should be familiar to you. You're going to put a friendly name of the certificate. You're going to put the domain name. You're going to choose your key. And then you need to make sure that you click this box down at the bottom that says, I understand ACM needs permissions to be able to renew the certificate when necessary. You may remember earlier on we set that permission on the CA side, but you also need to do it on the CSR side. Okay, so we've got, when you send that submit certificate signing request to the CA, it's going to show up with the status of pending validation, right? As the CA has to actually take that signing request and use it to generate a cert. Once the certificate issues, the status will change from pending to issued in the list of certificates in your account. In order to take it to our external system, though, we need to export it, right? So we got to export it out of the CA and put it on our external system. So you click on the certificate in the list, and then when you get to the details page, you're going to have a button here that says Export. You click that Export button, you're going to go to a screen where it asks you to enter a passphrase to be able to export your private key. This is important. You need to have the private key along with the certificate when you put it on your external system. So set a passphrase and click the button that says Generate PEM encoding, and then you're going to get returned a series of 3 links. Those 3 links are specifically linking to the certificate body, the certificate chain, and the certificate private key. You're going to need to download each of these onto your private system, and you can do it either by clicking the link and just downloading the file, or you can create text files in your system and you can copy and paste the resulting information coming from the link into that text file and put it on your system. Just remember that when you have them on your system, you're going to need to rename certificate.txt to certificate.pem and privatekey.txt to privatekey.pem in order to be able to use them for the next step. Okay, so we've got our certificate on our system. We've got our private key on our system, but our private key is currently encrypted. We need to decrypt that private key in order to be able to use it. So on a Mac or a Linux system, that's easily achieved using OpenSSL, using this command that I show here. You enter this command on your command line, and it's going to prompt you to enter that passphrase, right, that we created just a few minutes ago. Enter the passphrase, and you're going to get it's going to decrypt the private key and put it in the file name that you specify. So now that we've got that done, we have our certificate, we have our private key, we're all ready to go for using this with the IAM Credentials Helper. So, IAM Credentials Helper. This is, as I mentioned, it's a tool maintained by AWS that you can download. The tool is used to create a SIG-v4 signature that is sent to the Roles Anywhere endpoint using a create session API call. When you do that, the Roles Anywhere endpoint is going to send you back credentials in JSON format. So to install this tool, you can go to the Roles Anywhere user guide, where AWS has published links of the latest version of the Roles Anywhere Credential Helper. Or if you don't trust them and you want to build it yourself, go to the GitHub repo, download the source code, review it, and then build as appropriate for your system. So you need to download that helper, put it on your system in basically the same location where your certificate and your private key all are, right? That's the easiest way to use it. And don't forget to make your package executable, right? When you get it down there in the system, it's not going to be executable by default. You need to do the chmod commands to make it executable. All right, we've gone through a lot. You're probably ready to go to sleep, right? Let me walk you through now how you actually make this connection using Roles Anywhere. So, there are a few things we're going to need to gather before we actually issue this command to AWS. The first is we need the Roles Anywhere Trust Anchor ARN. So we created that Trust Anchor, and as with all things in AWS, there's an Amazon resource name that gets created that's associated with that. The second is the Roles Anywhere Profile ARN. Now both of these items can be obtained from the Roles Anywhere management page. Go grab those ARNs, put them in a text document on your system or wherever you want. Third is the ARN for the role that we're going to be assuming, and you get that from the IAM Roles page. And lastly, we need the file name for that certificate file and the decrypted private key that we have on our system. Once you have all these things gathered up, we're going to issue a command from the command line to get some credentials, right? And you're going to combine these items, and I'm going to walk you through how you combine that. First is we're going to execute AWS Signing Helper with the credential-process option, right? So this is saying run the Signing Helper application, and we're going to do a credential process command. Then we have a series of flags. We have our Trust Anchor ARN. We've got our Profile ARN. We've got our Role ARN. We've got our certificate and our private key. Can you imagine how fun this is going to be to type this out every time? So when you execute this command, send it to the Roles Anywhere endpoint, this is what you're going to get back. Woo! Inside that JSON document, though, you've got your access key ID, you've got your secret access key, and we have our session token. With these three things, you can set temporary environment variables on your machine to be able to execute CLI or API calls against AWS from that machine. So that's fun, right? Who doesn't love manually entering commands like that? That sounds like something I want to be doing on a regular basis. No. Let me show you something even cooler. So you can actually leverage the AWS Signing Helper as a custom credential process inside the AWS CLI, right? So to do this, you simply need to add a new entry to your AWS CLI credentials file to invoke it. First, we want to copy that certificate, that private key, and the Signing Helper application into the same directory where you have AWS CLI installed. Typically, it's going to be ./AWS or wherever you have it on your system. And then we're going to add a new profile to our AWS config or our credentials file that looks something like this. We have our profile name. I called mine Roles Anywhere, super creative. And then you'll notice it's very similar to that command line that we just issued, right? It's a slightly different format, right? We're saying, okay, we're going to use this credentials process, which is called AWS Signing Helper with the credential process option. And then I have all those same variables that I showed you before with the manual command. Once you've added this profile to your config file, you can call it for use with the profile switch, just like you would for any other profile on your AWS config, right? So AWS S3LS -profile Roles Anywhere. When you send that command, what actually happens behind the scenes is AWS CLI is going to invoke that Signing Helper application. It's going to send the request to the Roles Anywhere endpoint and pull those credentials back and set them. Nothing you have to do. You just send her that command, and it will send you back credentials. And you'll be able to, actually, it doesn't send you back credentials. It just executes the command using those credentials. So that, I think, is totally awesome. Very handy if you have an external system that you need to put this thing on to be able to make commands to AWS on a regular basis. All right, so I've walked you through the Roles Anywhere architecture. I've walked you through the components. I've walked you through a demo of how to actually use this. Here's my call to action for you. Go read the Roles Anywhere user guide. Preferably not right before bed, but at some point when you've had a nice coffee, go read that user guide. It goes in great detail about how the Roles Anywhere service works, how to set it up, and gives you code examples of how you can use it. Second, if you like this presentation and you want to see it in written form, I have a companion blog post on my blog at cloudyadvice.com. Basically, it's the same thing I just showed you today, but it's in written form. And then lastly, there's a presentation on YouTube from Reinforce 2023 with a customer, with Hertz as a customer, that walks through, it's an hour-long presentation talking about Roles Anywhere and how Hertz is leveraging it in their environment. So I encourage you to check out all these resources and hopefully go back to your environment and start stamping out the use of IAM access keys in your environment. So with that, I hope you found this talk helpful. I hope you can find something to take back with you. And I think we have time for questions if anybody has any. Have I rolled this out? Great question. No, I have not rolled this out. I want to. It's a question of time and priorities. I mean, because I've gotten those emails in the past, I hate IAM access keys with a passion. And my typical stance when I'm talking with a vendor is if they don't have native role support, then I'm not talking to you, right? You can just go away until you have that. But for one-off systems, right, where it's a homegrown system or something like that, this could definitely be a benefit. I've only rolled it out in the lab. I've not done it in production yet. So full transparency. Thanks, Blaine, for catching me.
Yeah, well, I mean, because I want to roll that out in the world. You know, you've got other devs or stuff.
Yeah. Yeah, so for developers, I haven't had a need to use this because we use AWS SSO, right, or IAM Identity Center. So they're just dynamically getting credentials that way. But for machine-to-machine communication, I think this is where this would be potentially handy. In the back?
If I accidentally upload my credentials to GitHub, how long does it take about for AWS to kind of like find it out and send me an email?
I don't actually know the exact time, but I'll tell you it's pretty fast. It's not like days and days. It's usually within a couple of hours, I think, that you get that email. Peter.
I think this would be really fun to roll out, but that $400 a month is kind of a killer. If you were to use a public CA instead, are there any downsides?
Not that I know of. I mean, like we have, in my company, we have a private CA that we operate ourselves. You know, it's based on Active Directory. You could easily leverage something like that for this service and not have to pay that $400 a month feature. I guess the question back to you is, how much is your time worth for maintaining that privacy? If it's somebody else's job, then no problem, right? But if the headache of managing and renewing those root certificates and those issuing CA certificates on a regular basis, there's a fair amount of toil there. But yeah, you could definitely do it with your own CA. And I don't believe there's any drawbacks to doing that.
Is there any way of being prompted for your secret to decrypt the key instead of storing it decrypted in the profile?
Well, you're not storing your secret in the profile. You're just storing the ARNs that call the Roles Anywhere process. So there's nothing actually secret stored in your profile. If you're doing the manual process where you're retrieving the credentials manually and then setting them as environment variables, then yes, it's stored. But if you're using the automate feature, let me go here. You're not actually storing any credentials here in the profile. You're just storing the ARNs. So I mean, I guess some people might consider ARNs to be secret.
No, at the end it says decrypted private key. Because with SSH, it'll prompt you to decrypt the key.
I don't know. I haven't tried that. That's a good idea. Yeah, so you're suggesting rather than pointing to the decrypted private key, point to the encrypted private key and then dynamically decrypt it at runtime.
Exactly. That way we avoid storing the credentials or storing a secret of some kind that if somebody got a hold of your laptop.
Right, because the private key is stored unencrypted on the system. I totally get where you're coming from. I haven't tried it. That might work.
Right.
That's a good call out, though.
Anybody else?
So
Hold on, let's get the microphone.
Currently, we are using the OIDC, the OpenID Connect. So, is this? I mean, even there, we are not entering any of our credentials, but we do give the ARN alone. We created the role, and we are giving the ARN, and that's how we are doing it. So, are you saying that this is better than that one?
I wouldn't say this is better than using OIDC. No, I'd say OIDC would be the better way to go.
Okay.
I think of Roles Anywhere as basically like a last ditch if you don't have a system that can natively assume a role using like a role and an external ID, right? If you don't have that capability. But if you've got AWS SSO or you have OIDC set up, I would say that's definitely better than this.
Okay.
Yeah.
Yeah, thank you.